The good news is, I think chapter 7 was the hardest chapter in this book. So what does that mean? It means this should be easier. That's correct. So section 8.1, I think you're going to like section 8.1. I think you'll find it to be a fairly simple one. All right, the law of sines. Here's what the law of sines is about. Up to this point in this course, we've dealt with lots of triangles. That's not how I wanted to draw my triangle. Except all the triangles we've dealt with have always been special triangles. They've always been right triangles. The law of sines and what we'll do in section 8.2, the law of cosines, give you a method for dealing with triangles that are not right triangles. All right, so typically we draw a triangle. I'm going to call this angle A, angle B, and angle C. So angles are usually given by capital letters. And the sides are given by little letters. So if this is angle A, side A is written over here, the opposite. And if this is angle B, then this is side B. And if this is angle C, that's side C. So the angles are given by capital letters, and the lengths of the sides are given by little letters. All right, now I'm going to take this triangle, and I'm going to draw a line right here. And I'm going to make sure that that's a right angle right there. That red side that I drew, that has a name. Anybody know what's that called? In a triangle? Well, if it will be opposite, because in a minute I'm going to talk about this triangle right here. But what I'm really looking for is, this is typically called the height of the triangle. So this side, I'm going to call this red side, I'm going to call that H for height. So do you know any famous formulas in triangles that involve the height?
Half the height times the base.
Gives the
Area.
Area is 1/2 base height. We'll talk about that in just a minute. All right, so now, this gives me two right triangles. It gives me this right triangle, and it also gives me this other right triangle. Let's start with this right triangle over here. What can you tell me about the sine of angle A if I'm using this right triangle? The sine of angle A would be H over B, opposite over the hypotenuse in that triangle. All right, so sine of A equals H over B, and I'm going to write that as H equals B sine A. Oops, wrong A, capital A for angles. And then I want to do the same thing in this triangle over here. In this triangle over here, what can you tell me about this angle B? Sine of B is in this triangle, what's the opposite? H is the opposite. What's the hypotenuse? A. So in this triangle, sine of B is H over A, which means H is A sine B. Well, if H is B sine A and H is also A sine B, then B sine A has to equal A sine B. Typically, we take this equation and we divide both sides by AB, and this gives us the law of sines. The law of sines says sine of angle A divided by sine A is the same as sine of sine B divided by side B. Questions on that? Now, had I wanted to, I could have drawn my, instead of drawing my line this way, making it perpendicular. I could have drawn it across the triangle this way and made a perpendicular line, and I could have gotten the same thing involving the angle C. And so I'm just going to throw this in without proving it, but it's also true that sine of C over C is equal to both of those two things. Questions on that? All right, so here's the kind of question you might see in this section. Angle A. How many degrees do you want angle A to be? Give me a number. 30 degrees. Angle B. It can't be 60. How come it can't be 60? Because then the third one would have to be 90 and we would have a right triangle. I don't want right triangles.
32.
32. Okay. And then side A is going to be, give me a number. 4. 4. And the directions will be solve the triangle. What do I mean by solve the triangle? Find all the other sides and all the other angles. All the missing sides and all the missing angles. All right, where do you want to start? Find the last angle. I think finding the last angle is the easiest one. How do you find the last angle? Okay, so I'm going to go 180 minus 30 minus 32. Same thing, add them up and subtract from 180. So I grab my calculator, 180 minus 30 minus 32. My calculator says 118 degrees. What's that? Well, yes and no. It's the same in the sense that angle A and side A are opposite. So in this case, we're saying that this angle A is only 30 degrees, and this angle B is 32 degrees. So it doesn't really match our picture because we just saw that this angle here has to be 118. So this is an obtuse angle, but that can happen. That's okay. So it's the same sort of picture. What we just decided is that this first angle is 30 degrees. This angle here has to be 118, which means it's more than 90. So that one has to be 118 degrees. And this one over here is 32 degrees. So we're looking at a triangle that looks kind of like that. What the triangle looks like really doesn't make all that much difference to us at this point. We can find angle C without really drawing the picture at all. Can I find side B? So far I know side A, which would be this one's 4. How can I find side B?
Would it be using the law of sines?
It's absolutely going to use the law of sines. And how would you use the law of sines?
So you could do sine A over A because you know the angle and then side A.
So I'm going to use sine A over A.
And then set that equal to sine, well, it would be sine 32 degrees over B.
Sine B over B, correct. Because what you always need to use the law of sines, you always need a pair. I need to have an A and an A. I need a pair like that. So you're absolutely right. I want to use sine A over A because I know both of those. And then I know B, so I can use sine of B. I can plug in all the numbers and then I can find little b. So we're going to have sine of 30 degrees divided by 4 equals sine of 32 degrees divided by b, and we don't know what b is. We're going to figure it out. All right, well, this happens to be very nice that you picked sine of 30 because that happens to be one that I know. Sine of 30 degrees is 1/2. And 1/2 divided by 4? 1/8. So I have, I ran out of room here, sort of. I'll write it up here, I guess. 1/8 equals sine of 32 degrees over b. And I'm going to use my calculator in just a minute here to figure out that sine of 32 degrees. But how do I get the b all by itself in this equation? I'm going to cross multiply. So if we have a fraction equals a fraction, we can use this cross multiply trick. So we're going to have b equals 8 sine 32 degrees. And I would grab my calculator. First thing I need to do is make sure that my calculator is in degrees mode. So I change the mode on my calculator. And then I go 8 sine 32. Calculator says 4.2393, long decimal going on forever and ever. I'm going to round off. Normally the directions would tell you round off to how many decimal places. Let's round this one off to 1 decimal place. So we would call it 4.2. All right, we're almost done. So far we found big C. We found little b. What's left? Little c. How am I going to find little c? Pretty much the exact same way, aren't I? I'm going to use sine of a over little a is sine of c over little c. And again, I just plug in all my numbers and solve. What's sine of a over a? 1/8. How do you know it's 1/8? Because we already did it. Do you need to do it again? No, you don't need to do it again. You use that information. That's 1/8 equals sine of 118 degrees over c. Again, we cross multiply. C is 8 sine 118 degrees. 8 sine 118 degrees is 7.1. There is a law of cosines. That's section 8.2. We'll do that on Wednesday. There is no law of tangents, though, as far as I know. I suppose we could make one up, but as far as I know, there isn't. Other questions? All right, well, it's not always quite that easy. Of course, right? That would be no fun if it was that easy. What if I gave you, I'm going to pick numbers out of the book that I know I'm going to work, I don't know where I'm going to work. C is, capital C, is 45.6 degrees. Little b is 42.1. And little c is 34.2. Notice on the first problem that we did, I gave you two angles. Where did it go? There it is. I gave you two angles. If I give you two angles, you can find the third angle very quickly and very easily, correct? Here we have a problem though. This time I only give you one angle. If I give you one angle, the problem can be more difficult. How come? What's that? I have to find two angles. That's true. Is finding the angle is going to be hard? Not terribly hard, actually. But here's the problem. I gave you that I gave you that C right here is 45.6 degrees. And I gave you one of the sides, B, let's say this one is B, 42.1. Here's the problem. There's different possibilities. This side C that I gave you, 34.2, it might be too short. What do I mean by it might be too short? It might be so short, there's 34.2, it might be so short that it can never come down here and hit. So what would that mean? It might mean it's unsolvable. So one of the correct answers might be unsolvable. There is no such triangle. That's a possibility.
How do you know when the angle's too small or too short?
We won't know until we try it.
Okay.
But I'm just pointing out that that's one possibility. One possibility is there might be no answer at all.
Okay.
The other possibility is that this might be long enough that you get two answers. There might be an answer here and an answer there. So you might have a acute angle here and an obtuse angle. In other words, you might get no answer. You also might get two answers. One acute angle, one obtuse angle. Or it's possible that this side, this 34.2, is just the right length that you only get exactly one answer. So that's how it gets harder. If I only give you one angle, there's possibilities. There might be absolutely no answer. There might be one answer. There might be two answers. And you're not going to know which one is going to happen until you actually try to solve it. All right, so let's actually try to solve it. In order to solve, I always need to have a pair. Do I have a pair? Yeah, I have a pair of C's. So I'm going to use sine of C over C equals sine of B over little b. And that's going to allow me to solve for big B, because I know big C, I know little c. I know little b, the only variable left will be big B. All right, so we plug in all our numbers. We have sine 45.6 degrees divided by 34.2 equals sine of B divided by 42.1. All right, once again, how do I solve that equation? How do I get the big B all by itself? First thing I do is I cross multiply. So I'm going to multiply that way, multiply that way. That's going to give me 34.2 sine B is 42.1 sine 45.6 degrees. And in a minute, I'll use my calculator and I'll plug on all this stuff. But let's keep going. I want that B all by itself. So what do I do to get the B all by itself? Divide by the 34.2. Sine of B is 42.1 sine 45.6 divided by 34.2. All right, I'm going to use my calculator now and I'm going to type on all that junk and see what I get. 42.1 sine 45.6. I'll show you what I'm typing in. I typed in 42.1 sine of 45.6 divided by 34.2. So really the only place I need the parentheses is around the 45.6. And I hit enter. And I get... And then I'm going to have to do the arc sine of that. You're right, to get the B all by itself. But here's what I wanted to do. I wanted to do this number first. Let's call this 0.88. Here's how you're going to know if this has no answer. The very next thing we need to do is we need to do arc sine. If this number right here turns out to be bigger than 1, then you know you have no answer. If that number is bigger than 1, why is that going to tell you there's no answer? Sine can't be above 1, can it? So if I'm going to do sine inverse, this number has to be between -1 and +1. Except here we're only dealing with positive numbers, so it really needs to be between 0 and 1. So that's how you know if you're going to get no answer. You grab your calculator, you type this stuff up. If this number turns out to be bigger than 1, you have no answer, because you can't do sine inverse of it. All right, so now I'm going to do sine inverse. And notice I really don't like to round off, so I'm going to use my calculator and I'm going to do sine inverse, and then I'm going to tell my calculator, use that answer. So I use this answer button, which is down on the negative key. It's okay to round off and write it down, but when you use your calculator, you don't want to round off until you have to. So I'm going to not round off using my calculator. And I hit enter. So B is, we'll round it off now, we'll call it 61.6 degrees.
So if that .88 had been like bigger than 1, there's never been no answer.
If this .88 had been bigger than 1, we would write no solution and we'd be all done. That's correct. That's the easiest one. How do you answer? Wonderful question. I was just about to ask that myself. All right, so notice here's the deal. Sine of b is a positive number. When I use my calculator and I use that arc sine button on my calculator, that arc sine button is always going to give me an answer in which quadrant? Always going to give me, since this is a positive number, that arc sine button is always going to give me an answer in quadrant 1. Is it possible that I might have an answer in quadrant 2? Yes, I might have an answer in quadrant 2. 61.6 is my reference angle. So how do I find the angle in quadrant 2? So I go, or B might be, I take 180 minus 61.6. And I get 118.4. All right, so I got two possibilities. B could be the angle 61.6, or B could be the angle 118.4. I'm still not sure if I have two answers or not, but here's how I'm going to find out for sure. Now I'm going to find angle A. How would I find angle A? I do 180 minus my 45.6 minus the 61.6, and that'll give me one possible answer. So A could be 180 minus 45.6 minus 61.6. And for that I get 72.8. Or, using this B, I would have 180 minus the 45.6 minus the 118.4. If this answer turns out to be negative, can I have a negative angle here? No. So if this angle, when I find A here, turns out to be negative, that means I only have one answer. If this A turns out to be a positive number, that means I have two answers. And in this case, it turned out to be 16, which means I do have two answers. So that's how you're going to find out if you have two answers. You're just going to try it and see if it works. In this case, it worked. I got two answers. Questions on that? Still not done. How come I'm still not done? I have to find side A. Not only do I have to find side A, I have to find it twice. Why do I have to find it twice? Because I've got two possible answers. So I'm going to have to find side A twice. Well, the good news is we do it the exact same way both times. I'm going to take sine of C, sine of 45.6 degrees, divided by little c, which is 34.2. And I'm going to set that equal to sine of 72.8 degrees over little a. So little a will be something, little a will be something else. All right, same deal. We cross multiply, and then we solve. So a sine 45.6 equals 34.2 sine 72.8. I grab my calculator. 34.2 times sine 72.8 divided by sine of 45.6 is 45.7 is what I got?
Yep.
And that's side, that's little a. Yep. And then finally I have to do it again. What's the only thing that's going to change? Instead of using the angle 72.8, I'm going to use the angle 16. So I'm just going to write it right here. I'm going to have A sine 45.6 is 34.2 sine of 16 degrees. That's the only thing that changes. The 72.8 changes to 16. All right, so again, I use my calculator. I type it all in. Yep. I got 13.2. Questions on that?
So there should be two answers for angle A, angle B, and then side A? Or?
Yes. If you get two answers for angle B and two answers for angle A, then you're going to get two answers, in this case, for side A.
So like we would write down two answers, like those would be all of our answers?
Correct. You would write your answer. Hopefully, you would write it nice and neat, just like this.
Including C2, or?
Well, you don't really need to include the C's because they were given to you in the original information.
Okay.
So why doesn't the C have two answers?
Well, we were given that information. We were told there's one angle for C and there's one side for C. We didn't have a choice. The same with side B. We were told there is side B. We don't have a choice. It only has one length.
Will we ever be given like angle C equals 45 or something else?
No.
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 So what would the triangle look like in that case?
What would the triangle look like in this case? Well, we would have two different possible answers. Let's see. One possible answer would be A is 61.6. So that's pretty big. 61.6. Oh, that's angle B, I guess. Angle A is 72.8. So this angle is the 72.8. And this one is 45.6. So we'd have one triangle that looks like that, roughly. The other possibility would be this angle B is 118.4, which means we have a triangle that looks like this. We have an obtuse angle, 118.4. And this angle up here, A, is very small. It's only 16 degrees. And then this one down here is still the 45.6. So you either have an acute triangle or you have an obtuse triangle. One of the angles is obtuse. The good news is that's as hard as it gets in this section. That's the hardest problem right there you're going to see. Questions on that? All right, there's one other thing in this section, and that's finding area of a triangle. How do you find area of a triangle? Area is 1/2 times base times height. That's very easy if your triangle happens to be a right triangle. If your triangle happens to be a right triangle, what's the base? And what's the height? Well, usually this side would be called base. And what's the height? The other leg. If you happen to have a right triangle, your base and your height are just your legs, not your hypotenuse. If you don't have a right triangle, it's a little bit harder. So I'm going to call this side base, and I'm going to call this angle A. If this side is the base, what's the height? I have to make a 90-degree angle. So that distance right there, that goes right from that angle down to here, it forms a right angle. That would be the height. And we'll call that H. All right, so this is angle A, which means this is side A. we'll call this, I don't know, what angle is this one? That one's B. So this is little b. And that would make this angle C, and would make this side, the base, would then be side C, wouldn't it? All right, so we know our formula for area. Area is, oh, I don't want to write A because that looks like angle A. Area is 1/2 base height. Well, I know the base is C. The base is C. How tall is that height? It's H, that's true. But I would like H in terms of maybe the other letters that I know in my triangle, A, B, and C. Well, we can do almost exactly the same thing we did for law of sines. Sine of A would have to be what? Use this triangle, H over B. Which means H is B sine A. So our area becomes 1/2, what was the base again? Little c, and what was the height? Little b sine A. Again, I could have drawn my red line, I could have drawn it other ways to get my height. And another formula is 1/2 AB sine C. Or yet another formula for area is 1/2, well, what's the third one? AC sine B. So you've seen the pattern. What's the pattern? Pattern is whatever angle you use the other two sides. It could be CAB. Yes, you could switch the order. And this one's typically written as BC sine A, but I just wrote it in that order because that's the way I have it down. All right, so these problems are pretty simple. I don't know. Give me an angle for A. 40 degrees. Give me a length for side B. 10 meters. We'll be working meters this time. And give me a length of side C. 14 meters. Find the area. You don't even have to draw the picture. That's right. The area is 1/2 times 10 times 14 times the sine of 40 degrees. All you have to do is plug in all the numbers. You grab your calculator. 1/2 times 10 times 14 times sine of 40 degrees. I get 44.995. I'm just going to round that off and call it 45 square meters.
So when we find the area, it's going to be one of those three formulas?
Yep. In this section, to find the area, you will use one of those three formulas.
You just have to know those ones.
You're going to have to know those ones, yes.
Can we write down and use them, or like memorize?
I would memorize them for now. Yeah. Other questions? All right.